Right, so we're looking at question 1 of the calculator statistics for the spring and the mass. Statistics and German, all in one question, my favourite. There's a couple of you obviously confused, and I suspect it's because of my translation more than the question. So I think this is what it's asking for. I think it wants you to physically draw the axes on a piece of paper. So add to your paper and put on the points. So not using the data, but actually just draw. And I think it's asking you to do axes from 0 to 1500, because in part C you actually equation of the line of linear regression, and it wants you to add that to your hand-drawn axis. So I think that although you can be using the calculator to calculate some of this stuff, the first part is just drawing a set of axes where the mass goes up to 1500, and you plot those 5 points on, and you just have a look at it and see what it looks like. And if you do that, it looks like a linear line. It's not perfect, but it looks fairly linear. So that's the first one. So just drawing a normal axis on the paper. The second one is saying something like justify why the and the mass are connected to function. So I think, but Alexia, if you want to have a look at it and just tell me if that's the right translation, I think that's what it's saying. So in this case, I've put the data into a graphs and spreadsheet page as normal, and I'm just finding a linear regression. I've sort of preloaded it because you're probably noticing that whenever I do any stuff on the calculator, there's a big delay between the voice and the thing. So I've just typed all this in, just normal, finding linear regression. I press OK, and we'll have a look what happens. Hopefully that's come up for you now as well. If not, it'll come up in a few seconds. So there's our linear regression. 0.03 is your M value, and 6.88, and it's a pretty strong linear regression, 0.9. So that is, I think you can say it. It looks like it's a linear function because it's got such a strong correlation. I guess, if I've translated that right. And then I think it says for C, I think it says actually find the linear regression function, which we've just done, and then physically add it to the graph you drew in part 1. And this is why it said to go up to 1500, because you can then check for D, you can check that the answers you're getting for D make sense on your graph as well, I guess, because I think that you're going to find that using your regression function. So I mean, I'd be, when it says find what it is for 1.5 kilograms, I'd be now going to a calculator page using my f whatever function. I'm not sure what it is on this one because I've got loads of other stuff on there, but I think if you're doing it on a fresh document, you'll use the f1, do f brackets f1 brackets 1500 close brackets equals, and that'll give you the length of the spring when the mass is 1500 grams. Be a bit careful with the units there, because you found a linear function connecting grams and centimeters, not kilograms and centimeters. And then you're going to go the other way. You're going to do that solve f1 brackets x equals 31.4, and that'll tell you what the weight is of the leaves an extension of 31.4 centimeters. For f, how long is it in its starting position? Well, that's going to be when x is 0, so you can either do f1 brackets 0, because then there's no mass added, close brackets equals, but also you can just see it's going to be, if x is 0, then it's going to be 6.88 centimeters, so that must be the starting length of the spring. And then for G, this is where I'm a bit confused, because I'm not entirely sure why. If in B we've said it's a linear regression because the correlation is very close, I think here it's saying justify why the linear function, linear regression, fits the data, which you know, or how well does it fit the data? Well, again, that seems to be a correlation thing. So maybe, Alexia, if you have a look at the question, can you just tell me what the difference is between B and G? What's the difference between what it's asking? Because I can't really decipher the German to see what it's asking. If you add some stuff, I'll put another answer on. So there we go. That's that. So we've got drawing it in part A, finding the linear function in B, adding the linear function to your graph in C, using your function to find a length for a given weight and a weight for a given length for D and E, finding the starting position, which is easy, and then I'm not sure, G might be something to do with B, but Alex is going to clarify that for us. I was going to show you one more thing as well. It's not necessary for this question, but if you open up a what's it called? Hang on. Let's see. Okay, if you go to add page, number 5, add data and statistics, you get this. I think I showed you this, but just to remind you, because we didn't use it much. Click to add variable. Well, we've got a load of variables here, so we're going to have mass along the x1, and then click here, length on this side one. Just pause for a bit and let the video catch up. So you can have a look and see what it looks like without having to plot it physically. And also, if you then go to menu, analyze, 6 regression, show linear, and then you've got all the other ones as well, but linear in this case, and it will give us the same linear function. It doesn't give us the regression coefficient, but we can sort of see that it's a linear regression pretty well there. So that's a slightly shorter way of doing it. It's not totally applicable to this question, but just I thought I'd remind you about that just in case it helps in any other questions. Okay, I hope that's enough. Now I just need to work out how to stop this. There we go.